Remember trig identity of the form. If you add 1 and tangent squared of alpha, it's always equal to secant squared of alpha. This is one of the trig identities, trig properties that you learned before. Now that we introduce hyperbolic sine, hyperbolic cosine, hyperbolic tangent, and so on, we're interested in knowing, can we find a relation between tangent and secant in hyperbolic form? So recall that hyperbolic tangent of x is equal to hyperbolic sine of x divided by hyperbolic cosine of x, which in turn is equal to e to the x minus e to power minus x divided by e to the x plus e to power minus x. The way that we defined hyperbolic secant, it is 1 divided by hyperbolic cosine of x, which in turn is equal to 2 divided by e to the x plus e to power minus x. Well, the question is, can we find a relation here between hyperbolic tangent squared and hyperbolic secant squared? What is the relation between hyperbolic tangent to the secant and hyperbolic secant to the secant? I'm going to investigate a relation between these two. So in our very first step, we're going to raise them to the second power and see what we have. All right. Okay, very good. So let us begin. If I take hyperbolic tangent of x and raise it to the second power, I'm basically taking e to the x minus e to power minus x divided by e to the x plus e to power minus x to the second power. What's the meaning of that? It means that I can take the numerator e to the x minus e to power minus x to the second. I'm taking the denominator and raise it to the second power separately. Or basically, what I'm going to do, I'm going to either apply algebra or use distribution. Either is fine. E to the x plus e to power minus x times e to the x plus e to power minus x. In either case, I'm going to take this quantity and distribute it into parentheses, take the second quantity and distribute it into parentheses, put it on the numerator. So this guy can be written as, in the long division part, you get e to 2x minus e to the x times e to power minus x minus e to power minus x times e to power x plus e to power negative 2x. And then on the denominator, what do I have? I'm going to do the exact same thing. I'm going to take this guy, distribute it into parentheses, and then take this guy, distribute it into parentheses, then combine like terms. So I end up with e to power 2x plus e to power x times e to power minus x plus e to power minus x times e to power x plus e to minus x times e to power minus x, which can be written as, so here you have e to 2x, and as you remember, if you combine these together, okay, let me write it in red. So e to x times e to power minus x is e to power 0 or 1. So wherever you see e to the x times e to power minus x is just 1, both on the numerator and the denominator. This is basic algebra, everybody. So you have minus 1 plus e to power minus 2x divided by e to 2x plus 1 plus e to power minus 2x. So this guy can be written as e to 2x minus 2 plus e to power negative 2x divided by e to 2x plus 2 plus e to power negative 2x. So far, I just found the hyperbolic tangent to the second power. Next, I'm going to take hyperbolic secant and raise it to the second power and find a relation between these two. What else you could do? You could also divide this by e to power 2x and simplify as well. So here you could also write this as e to 2x minus 2 plus 1 divided by e to 2x divided by e to 2x plus 2 plus 1 divided by e to 2x. In turns, if you take the common denominator, you get e to 4x minus 2 e to 2x plus 1 divided by e to 4x plus 2 e to 2x plus 1. So this is all tangent, hyperbolic tangent to the second power. Now let us move on and work with hyperbolic secant to the second power. So for hyperbolic secant of x to the second power, remember the definition. When you're talking about hyperbolic secant, it is 2 divided by e to the x plus e to power minus x raised to the second power. What do we have? We have 4 over e to the x plus e to power minus x to the second power. Okay. Let's do the algebra. You have a 4, you have e to the x plus e to power minus x times e to the x plus e to power minus x. Do the algebra as usual. Distribute e to the x into parentheses. Distribute e to power minus x into parentheses. So what do we get? This guy is equal to 4 divided by e to 2x plus e to x times e to minus x plus e to minus x times e to x plus e to power minus 2x, which can be written as 4 divided by e to 2x. And remember that all of these numbers are equal to 1. So you get plus 1 plus 1 plus e to power minus 2x. In turns, it can be written as 4 divided by e to 2x plus 2 plus e to power negative 2x. Again, you can simplify this further, everybody. You can write this as 4 over, you have e to 2x plus 2 plus 1 divided by e to 2x. When you take the common denominator goes on the numerator. You end up with e to power 4x plus 2 e to power 2x plus 1. Very good. So see what happened, everyone. Take a look. Let me rewrite this for you down here so you can just compare these and decide on the mathematical operation that you're going to use between hyperbolic tangent squared and hyperbolic secant squared. So far we just showed that the hyperbolic tangent to the secant is equal to e to 4x minus 2 e to 2x plus 1 divided by e to 4x plus 2 e to 2x plus 1, and then hyperbolic secant to the secant is 4 e to power 2x divided by e to 4x plus 2 e to 2x plus 1. Okay. So the denominators are the same, right? You have the same denominator. If I add these two together, now add them. Add these two quantities. This happens. I'm going to use the same color, hyperbolic tangent squared plus hyperbolic secant squared. Well, let me use the same color for hyperbolic secant so we see everything in their own color. This can be written as, so e to 4x minus 2 e to 2x plus 1 divided by e to 4x plus 2 e to 2x plus 1 plus the second function, which is 4e to 2x divided by e to 4x plus 2e to 2x plus 1, the same denominator. So this guy in turns can be written as, now let me use a solid color because I'm combining these together. This in turns becomes e to 4x minus 2e to 2x plus 1 plus 4e to 2x, and the denominators are the same, so you just copy one of them down. E to 4x plus 2 e to 2x plus 1. Well, on the numerator, I have e to 4x. And if I combine these two together, negative 2 e to 2x and 4 e to 2x, it becomes plus 2 e to 2x, and then I have a 1 down here. If I divide this guy by e to 4x plus 2 e to 2x plus 1, hey, I have the same quantity on the numerator, the same quantity on the denominator. They disappear. This becomes just 1. Wow, isn't that interesting? We found a relation between hyperbolic sine squared and hyperbolic cosine squared. We just showed that hyperbolic tangent to the second plus hyperbolic secant to the second is always 1. And we also showed that hyperbolic cosine squared minus hyperbolic sine squared of x is also 1. Two important identity for hyperbolic quantities. So these are hyperbolic identities, all using the direct definition and algebra for you, everyone. So make sure to raise everything to the second power correctly, take the common denominator, don't skip any step, then you feel comfortable about these types of questions.